everybody, this is Bruce at Groxio Learning, and I've got the dog on the floor. Today we're going to talk Tetris, and we're going to implement colors. So I want to take a look at a bug that we left in last time. Did you catch it? So if I reload enough times, I bet, oh, there it is right there the first time. It seems that there's a J shape that we didn't catch. So that means that there's a bug that we ought to get committed before we actually fire this checkpoint. So let's fix that before we do anything else. So let's read what this says. So this is telling us that we don't have a matching function clause in tetromino.points. And it looks like it's sending its, these are the clauses that it tried. And there's some more below. But it looks like it's sending a J. So I bet that we forgot to change something in the J. So we're looking in tetromino. Yeah, look at that. L and L again. There's probably a compiler warning sitting on us, sitting there waiting for us. And we didn't catch it. So we basically paid the price. So let's see if we can't reload this. There's a J. And there's an L and a Z, another Z. We got a lot of Z's in a row. Okay. Yeah, that looks better to me. And I want to make one more tiny tweak before we checkpoint again. We have this odd, I basically grabbed some HTML code from the web and it works, but I want to do something that's a little bit prettier, and I want to use standard HTML colors. So we're in Game Live here, and recall what's happening is we're going to stuff the initial pass. We're going to come in through the router right here. Somebody's going to type game, and we're going to go to the Game Live module. And the first thing that's going to happen when we hit this Game Live module is we're going to hit this mount function, and we're going to initialize the data for this live view, which is a socket. So one of the things that we can do to make sure that this is stable, that the connection is stable when we actually fire it, is I could say if connected, do, then do all this stuff. And so this way it'll make sure I'm connected on the socket before I start that timer. And that's probably a good thing for me to do, to make sure the connection stabilizes. This is more of an ensure connected than anything else. So we're initially setting up all the data for the live view, and then what's going to happen is our application is going to happen in two pieces. One, we're going to render one static view for the chunk of data. So for any given chunk of data, I'm going to get a view. Right? And then based on things that happen in the real world, when events come in, like for example, the tick of a timer, then we're going to implement things that change my data. And then when the data changes, then you render again. So our strategy for rendering a whole game is not to deal with any motion or anything like that. Our strategy is just rendering the next socket, the next frame of the game, if you will. And so this render, I'm going to, this is basically my debugging area where I'm just inspecting a little bit of code. This will disappear for our production code. But I have this thing called render board, and the render board is doing the work in here. And so here we're rendering all the points. And one of the things that you notice is that a point is an X and a Y. And you can see that we're rendering the color in this kind of sophisticated way. I don't need sophistication here. I just need a valid HTML color code. So I'm going to hard code that to red. And I think that what I'd like to do is actually, rather than saying that a tuple is an X and a Y, Well, it really matters. The shape that this came from really also matters. And the reason is that shapes in Tetris have colors. And actually, it's important for people that play the game a lot to see shapes and colors that they recognize. But we're not going to try to stay true to the regular Tetris colors. We're just going to assign some random colors to ours. But what I'd like to do is make this a 3-tuple, right? So that when I'm building a point, maybe the very last thing that I do after I move everything around is that I take my points and I add a color to it. So let's see what that might look like. So I have a tetromino and a color. So this is going to be, instead of XY, this will be XY and Z, or XY and C, right? XY and C are the color. So in here, I'm going to actually drop the color. No, this is a shape, isn't it? So I'm going to drop the color for a shape. And right there. And so the color, and I'm going to take a shape. So right now I'm always going to return red. So this is a one-line version of a function. I think that sometimes when I'm going to have a bunch of functions side by side like I will here, then this is a good shape for a function to have. So this is going to break for me because this pattern isn't going to match. So what we'd like to do is within our tetromino, well, let's see this break here. So within my tetromino, I need to also be returning the, I need to add the shape to all these things, right? So maybe what I'll do is, I'm going to say points.add shape. So in the points.add shape, I'm going to have a point and a shape. And actually the point is going to come in a form of an X and a Y, and that's going to take a shape. And I'm just going to return X, Y, and the shape. So that looks good to me. And just in case a point comes in that already has a shape in it, so I'm going to call that a point with shape. Actually, this needs to be on point, doesn't it? Because the reducer, I want the first argument to be a point. Def add point, or add shape. And this is a point. So this actually is a not a reducer anymore because it's no longer going to return this. This is going to be a transformer. And this is going to have a shape. And here we wanted to take this as an X and a Y. And we're going to return X, Y, and the shape. But if somebody gives me a shape that already has a point, I can ignore this shape and I can just return point with shape. And now this can go away. Holy cow, I got lost here, didn't I? So I'm on point, and now all of this can go away, right? You know, I think I like the multi-line version better even here, just to keep things with the common shape all up and down my code base. So I'm going to do that. And so now everything has a point with a shape, and let's see if things are happy. Doesn't look like we're happy right now. So we're saying we haven't got a matching clause, the points.add shape. And that's because we moved that to point, and we want this def points.add shape. I'm in points, man. So now I'm going to take points, shape, and I basically want to do this, right? You know what? I'm just going to make this a one-liner. enum.map. And that's going to take points, and I can now use the function exactly as it stands. Actually, no, I can't, can I? I need to grab that same shape that I did before, right? enum.map, and I'm going to get a point, and I'm going to say point.add shape, point, and shape. Let's see if this is a little happier now. Unexpected token of points 13. So, yep, we didn't end this function, did we? Like that. How's that? Okay, so basically we're moving on down here, but it looks like we're not rendering things correctly yet. So let's see what's happening here. So I bet it's related to our live view, our game live. So the color for the shape, this is always going to return red. And so let's see. Oh, that's page live again. So in the game live, the color is always going to return red right here. So the color for the shape, this should be doing a fill. Ah, look at that. So I'm doing the old school string interpolation, and I want to be dropping this in like that. So there we go. Yeah, so now I'm getting red. And so now my job is to do a little bit of implementation here. So I need to handle the colors for the various shapes, right? So maybe the shape for an L is red. Actually, maybe I want to keep a default, right? And then I want 7 of these, right? 1 for each individual type of color, right? And so let's see if we can remember them. L, and the mirror of that is a J. The other 2 mirrored ones are an S and a Z. And I've got an O shape, which is the round one. I've got an I shape, which is a vertical one. And I've got the T shape, which is the T. And so that's going to be red, blue. I need some more HTML colors, don't I? HTML, CSS colors, color names. This is exactly what I want. So what are some fun ones there? So we have blue, violet, brown, chocolate. Coral looks pretty. We're going to need red. So let's see. Going to need green. Lime green's prettier than green. And we had, so what are some other ones? Magenta. So we got a purplish looking thing. We have a green looking thing. So how about a royal blue? That's pretty. And so now we need something pretty bright. How about, oh, the magenta was bright, wasn't it? There's a red, sienna. So how about silver? So there's a red, there's 2 reds right there. So, is there a yellow? Is that going to be too bright? That's going to look okay. And do I have a gray? No, I do have the silver. And how about a saddle brown? Let's see what these look like. So there's a green. I'm going to reload. Magenta, blue, brown. Yeah, so these look great. And so now all of my individual bars have colors. And let's talk a little bit of strategy for what's going to happen next. So one of the things that protected us from our code is that we actually made a pretty substantive change in that we changed the shape of all the points in the system. But one of the things that we did is we basically followed our rule of reducers. Recall that we had a shape of a pipeline. So we had this thing called a origin. Not an origin. This is a, let's say we have a function called constructor. And the constructor basically would return a whatever my thing is, right? And then we had a couple of different types of reducers, right? So one of them would be reducer left function, and then I had x, y, and this one would return left is x minus 1 and y. And then we had reducer right, and this is x plus 1, and then we had a reducer down. So anyway, the point is that all of these reducers will allow me to stay in the same neighborhood for a while. And only after I leave this reducer and move away from points and into something else, like a point with a color. So that is called a transformer or a converter. And the one that we had was a point and a shape. And this returned X, Y shape. And so the pattern that I lived with for a while is I had the constructor, and then I could feed that into reducer, and feed that into, I could do these all day. Remember, since these are anonymous functions, I have to have that weird extra period and the parentheses. Then maybe I want to move down one. So I could stay syntax error before reducer down. Oh, I never did a pipe here. Yep. Okay. So I can stay in this neighborhood for a while as long as I stay in reducers. But the minute that I cut over to something that changes the shape, then this thing is a converter, right? So I can't reduce anymore. So if you look at converter, and let's take a shape of an L, right? Okay, so this converter now has taken me into this code. But if you look at it, what we actually did in the tetramino is I have this idea of show, right? And that's actually the main manipulation function here that gets me ready for my LiveView to render, right? And so my show says constructor, or just an element of data, reducer on points. This actually converts me to points. And so that's a converter that takes me to points. But now I can live in the points land for a while, right? And I can call a couple of reducers here. And along the way, we're going to have a couple of more of these. We're going to have a points reducer to rotate the shape appropriately. And when we're done, we're going to be left with a bunch of points with a shape. So I want to point out one more decision that we made here. We decided to add a shape here instead of adding a color, and we did a conversion to color on the user interface side. Why? Because the tetromino should not know anything about the way it's rendered. It only needs to know that the user might decide, or the programmer might decide to render things differently. So it would be nice to have this extra shape in the list of points. So what we have here, if we look at the design of our live view, so we have a chunk of points here that we're going to render. And it doesn't matter if these points come from a tetromino or if they come from the rest of the board. Every single point in here knows the shape that it came from, so it can preserve its color. So once we convert to this set of points, we don't have to do any other conversion at all, which is a really nice thing. So what we're going to do next is start to work on the manipulations that we'll need to do to rotate our shape. And that's going to be cool. We're going to use a lot of piping and a lot of really simple geometric conversions to get to some pretty sophisticated behavior in the rotate. And that we're going to save for next time. So this is Bruce and the dog on the floor for Groxio Learning. We'll see you next time.